The James Webb Space Telescope, humanity's most advanced observational tool for exploring the universe, has recently captured an extraordinary and puzzling phenomenon: mysterious glows emanating from a planet nearly 4 light-years away. This unusual light appears to originate from Proxima Centauri b, the closest known exoplanet to Earth. The discovery is raising profound and potentially historic questions. Could this be the first artificial illumination we've ever detected from an extraterrestrial civilization? Though it may sound like science fiction, the data behind this observation is grounded in reality. During its infrared survey of Proxima Centauri b, the James Webb Telescope detected recurring light pulses that seemed to regular, to patterned, and too persistent to be the result of natural processes. Unlike natural events such as auroras or volcanic activity, which scatter light in random, unpredictable ways, these emissions exhibit a consistent structure suggesting a possible artificial origin. Proxima Centauri b is an exoplanet orbiting the red dwarf star Proxima Centauri, part of the Alpha Centauri system and the closest stellar neighbor to our own Sun. This planet resides within the habitable zone of its star, meaning its temperatures could allow for the presence of liquid water. Scientists have long speculated that, among the planets in our cosmic neighborhood, Proxima Centauri b may be one of the most promising candidates for life. Yet never before has such a compelling clue emerged: not a traditional biosignature, but something potentially even more exhilarating: what appears to be artificial lighting on the planet's dark side. Unlike Earth, which rotates and shares sunlight across its surface, Proxima Centauri b is believed to be tidally locked, with one hemisphere perpetually facing its star while the other remains in eternal darkness. If life has developed there, intelligent beings might have adapted to the constant night by creating artificial illumination. The data from the James Webb Telescope indicates consistent, faint emissions in the infrared spectrum originating from this dark hemisphere. These emissions do not appear random. Their fluctuating brightness mirrors patterns similar to city lights observed from orbit around Earth. Astronomers, including David Kipping from Columbia University, have expressed cautious optimism about these findings. He notes that this is not simply background noise or a technical anomaly. Something in this data warrants deeper investigation. The concept of artificial lighting on an exoplanet is not taken lightly, and confirming it would require unraveling multiple scientific layers. Proxima Centauri, the star around which this planet orbits, is a red dwarf smaller and cooler than our Sun, but far more volatile, frequently unleashing intense solar flares. Such activity could strip the atmosphere from nearby planets, making them inhospitable. However, if Proxima Centauri b retains a dense enough atmosphere, it might be able to shield itself from this radiation and remain suitable for life, or even for an advanced civilization. One of the most vital methods in exoplanetary research is atmospheric spectroscopy. By examining how starlight filters through a planet's atmosphere, scientists can detect specific gases that might indicate life, such as oxygen, methane, and ozone. Although the James Webb Telescope is optimized for detecting infrared light, which is particularly good for identifying compounds like water vapor, methane, and carbon dioxide, the discovery of unusual chemical signatures becomes especially compelling. In the infrared signal from Proxima Centauri b, researchers have found abnormally high concentrations of methane without corresponding levels of carbon monoxide. On Earth, such a chemical imbalance is usually attributed to biological activity or industrial processes. This unusual atmospheric composition on Proxima Centauri b may suggest either a complex biosphere or a technologically advanced society capable of altering its environment. Further intensifying the mystery is the possibility that the observed light pulses might not be urban lighting at all, but rather a form of communication or signaling system. Some scientists hypothesize that advanced civilizations may use modulated light, such as lasers or energy pulses, to signal their presence. Historically, the search for extraterrestrial intelligence SETI has focused on detecting radio waves, but telescopes like James Webb allow astronomers to to look for such signals in other parts of the electromagnetic spectrum, particularly in the infrared, which is better at penetrating interstellar dust and planetary atmospheres. There's also a more speculative theory. The lights may not originate from structures or beacons on the surface, but from orbiting technology. These could include satellites, solar arrays, or other reflective constructs. If an advanced civilization exists on Proxima Centauri b, they may have developed large-scale infrastructure to adapt to the planet's extreme conditions, perhaps giant reflectors to brighten the night side, or orbiting solar collectors powering subterranean cities. Of course, natural explanations must also be considered. Could these lights be from geological sources such as volcanic eruptions, geothermal vents, or luminescent minerals? While theoretically possible, these processes typically produce erratic light. The consistent symmetry and regularity of Proxima Centauri b's light emissions challenge the idea that they originate from chaotic natural sources. Instead, their measured, rhythmic intensity is more reminiscent of Earth's energy consumption patterns during nighttime. Another major hurdle in observing exoplanets is the overwhelming brightness of their host stars. A star like Proxima Centauri can outshine its planets by several billion times, making direct imaging nearly impossible. The James Webb Telescope overcame this obstacle using a coronagraphy device that blocks out a star's light, allowing dimmer planetary light to become visible. Future missions are expected to take this capability even further. NASA's upcoming Habitable Worlds Observatory will feature even more advanced methods for blocking starlight. Another proposed tool, the Starshade, is a vast, flower-shaped spacecraft designed to fly tens of thousands of kilometers in front of a telescope, casting a shadow and enabling direct imaging of Earth-like planets. Ground-based telescopes, like the extremely large telescope ELT now being constructed in Chile, will also play a critical role. Using adaptive optics to sharpen their vision, instruments like the ELT scheduled to begin operations by 2028 may help confirm whether the lights on Proxima Centauri b are artificial or if they're caused by an unfamiliar natural phenomenon. If these mysterious emissions turn out to be artificial, it would be among the most revolutionary discoveries in human history, the first tangible indication that we are not alone in the universe. Consider the possibility an intelligent species orbiting our nearest stellar neighbor, just 4.4 light-years away, perhaps aware of us just as we're beginning to detect them. What might their civilization be like? Would they be peaceful explorers, highly advanced technologists, or survivors of a harsh and volatile environment? Such questions go beyond science and enter the realm of philosophy. But that's the power of discoveries like these. They expand our imagination and challenge the boundaries of our understanding. While skepticism remains essential, science demands evidence, and rigorous astronomers are calling for further study. Proxima Centauri b deserves more detailed observation from every available platform, whether from space or ground. New angles, deeper scans, and coordinated international efforts could help determine the true nature of these lights. Even if these signals are ultimately found to be natural, the very possibility that they might be artificial is transformative. It shifts our view of the universe from a vast, indifferent expanse to a place where signs of intelligence may be flickering just beyond our reach. If these lights truly do originate from an intelligent civilization, then perhaps they've just taken the first step in saying, "We are here," and that alone could make this one of the most exciting and significant moments in the history of space exploration.